you, it's me. Let's talk about two-pointers. It's easy to mix up different patterns with two-pointers. All two-pointers is really saying is that we're going to use two or more pointers to access different elements at every iteration while processing an array. Now, what happens at each iteration is pretty much up to us. It could be something simple like reading the element at the pointer or directly modifying that array. For us to get a good sense of two-pointers, I wanted us to look at something simple. Say we have a sorted array that has at least one duplicate value. In this example, we know the length of our array is 6, and we could be asked what the length of this array would be if we removed any duplicate values. We can see we have one duplicate of the element 4. If we remove that, then the length of the array will be size 5. And by identifying that second 4 and removing it, we constructed a duplicate-free array. At first glance, this definitely seems pretty simple. There are even data structures that would help with this. We could dump all the elements from the array into a set and then convert that back to an array. And depending on the implementation, this could cost us ON linear time. Except if we want to count a lookup inside of a set to make sure that the value is not a duplicate, that would be OM, where M is the length of the set. So to convert an array into a set would be ONM space complexity. Let's add a constraint to our problem statement. And this is a key to identifying if a problem could be potentially solved by a two-pointer pattern. With the exception of the array itself, maintain O1 space complexity. You might also know this constraint as modify the array in place. So now we know that converting the array to a set and back to an array is not an option for this problem. But what does that constraint even mean? Well, we could put it another way and think of it as being asked to reorder all the elements in the array so that all the non-duplicates are at the beginning. That means our original example would go from this to this. We can ignore the question mark for right now and just pay attention to the first 5 indices. That represents the new duplicate-free array. And anything after the 5th elements does not matter to us. It's just some copied over value that already exists within the duplicate-free portion of the array. So when we get asked to modify the array in place, we might be asked to return the index of the last duplicate-free number, which in our case would be 4, or to return the length of the duplicate-free array, which is 5. So now we want to think a little bit about how we actually would construct our duplicate-free array. Let's assume that we iterated through the whole array from start to end. Remember that our goal is to build a duplicate-free array. So that means that at every iteration, we want to copy over an element if it's one we have not seen before. And here's where we take advantage of the fact that the array is sorted. At any given index in our array, if the index is larger than 1, if that index had a duplicate value, then that value would be equal to the element at that index minus 1. Let's take this a step further. If we maintain the index plus 1 of the latest element that we copied into our duplicate-free array, and at every iteration we checked whether the new element we're visiting equals the element at the latest index minus 1, then we'd know whether or not the index that we're visiting contains a duplicate value. So say the index that we are visiting does contain a duplicate. Then what? Well, since we want a duplicate-free array, we ignore it. And in the case that the element at the index that we're currently visiting is not equal to the latest index minus 1, then we'd copy this freshly seen element into our array at latest index and increment our latest index by 1. And that's the basics of how to use two pointers to create a duplicate-free array. We can now get our fingers moving and solve a problem. Number 26 on LeetCode, remove duplicates from a sorted array. Given an integer array nums sorted in non-decreasing order, remove the duplicates in place such that each unique element only appears once. The relative order of the elements should be kept the same. Since it is impossible to change the length of the array in some languages, you must instead have the results placed in the first part of the array nums. More formally, if there are k elements after removing the duplicates, then the first k elements of nums should hold the final results. It does not matter what you leave beyond the first k elements. Return k after placing the final result in the first k slots of nums. Do not allocate extra space for another array. You must do this by modifying the input array in place with O1 extra memory. In this problem, since we're looking for non-duplicated values, I'm going to name the pointer that represents the end of the non-duplicated array next non-dupe. This is just to help us visualize what the purpose of this pointer is. Because we're going to be comparing this to our I pointer, we can initialize it to 1. Because there's no reason that they both start at the same position. Our I pointer will be declared as a part of our for loop, because we're just going to have it move forward with each iteration of the array. This will represent our visited index at each iteration. Inside of our for loop, we're going to create an if statement. This checks if the value of nums index next non-dupe minus 1 is not equal to the value at nums index I. If they're not equal, meaning nums index I is not a duplicate of the value to the left of our next non-dupe, then we'll update the value of nums index next non-dupe to be equal to nums index I. This is basically just replacing the elements and allowing us to rearrange our array in place. We will then increment our next non-dupe pointer by 1, because now we're ready to check other elements in our array. After we've traversed over the whole array, we will return our next non-dupe pointer. We can notice that our next non-dupe pointer is not the last index that we copied into in the array. That's because the problem statement here specifically asked for the length of the non-duplicated array, which would be our last index plus 1. And that's what our next non-dupe represents. And that was using the two-pointers approach to remove duplicates from a sorted array. Two-pointer problems come in all shapes and sizes. We'll definitely dive into more problems using this pattern. But in this problem, we just basically used one pointer as an iterator and one pointer as a placeholder. I hope this all made sense and you were able to follow along and solve the problem too. Don't forget to like and subscribe. Leave me a comment if there's any pattern, algorithm, or problem on LeetCode that you want to go over. And thank you so much for spending your time with me. So from me to you, have a great day.